All right, hello everyone, and welcome to the Marshall W. Allworth Planetarium. My name is Jessica, and I will be your guide to the strange things in space this evening. You've also met Braden, one of our students here, who's helping out with the show. So for the show, we're looking at strange, bizarre things in space. There are going to be some things that are some mysteries that we don't quite understand yet, some things that were a mystery, but we do kind of think we know how it works, and then just some really cool things that I thought were weird as well to throw in there. Now, if any time during the show you have any questions, feel free to just ask. I can't always see hands at the back, so you're welcome to just ask your question out loud. If you don't feel comfortable doing that, you can also come talk to me at the end of the show and ask your questions. If you need to leave at any time during the show, you'll exit through this door here, which I'm about to close. Just be careful, it does get dark in here as you're leaving, and if you need bathrooms anytime during the show, they're out in the main building entrance by the big telescope. Yeah, I think that's it for me for now. I'm gonna get this door closed and head to the back, and we'll get started. It's okay. All right. As I mentioned, for our show tonight, we are going to be looking at strange and bizarre things that we can find in our universe. We're going to start off with a couple of strange things within our own solar system, and then we'll move kind of further and further out into the universe. So, our first stop this evening is going to be over at Saturn, the second largest planet in our solar system. Now, you may have heard Saturn called a gas giant. That's actually a bit of a misnomer. It is mostly hydrogen and helium, which on Earth does exist as a gas. But in the intense pressures down inside of the planet, the gases actually get squeezed into a liquid. And so the bulk of the planet is liquid hydrogen and helium. But the very outer layer, which we call the atmosphere, is gaseous. And it's this atmosphere that we're going to be looking at. So from here, when we look at Saturn, we see these nice stripes of clouds. And every so often, we'll see kind of little storms circling around in those clouds as well. But what's strange about this planet is at the pole. So let's go look at the North Pole of Saturn. It has this strange hexagon feature. This hexagon is actually a massive hurricane with wind speeds up to 200 miles per hour. And I mean giant when I say giant hurricane. One side of the hexagon is larger than the diameter of the Earth. Each side is about 9,000 miles long. It is absolutely insane how giant this storm is. And of course, the shape of it, a hexagon. When we see storms in other places, both on Earth and on other planets, they're circular. So how can a hexagon shape form naturally? And that's been the big question that astronomers have been trying to answer since we first saw this hurricane during one of the Voyager flybys back in the 1980s. Well, this is one strange thing that we do think we might have solved. Because of the way the gases flow around each other. If you have some gases flowing around at different speeds, they can interact and form eddies and vortices. So let's look at a little simulation that some people ran in a lab. We don't have to worry about, the math at the beginning, but what we have going on here is two fluids moving at slightly different speeds. And as they interact and they form these eddies and these whirls, the way they're spaced out actually can naturally form a hexagon shape. So this is in fact a shape that you can get naturally. In fact, depending on the parameters, how these fluids are flowing, you can get other shapes too, like triangles and squares and other polygons as well. So, okay, we do kind of understand that this shape can be natural if you have the right conditions going on. But it's still a very large structure that has been going on for, at least 40 years, possibly longer. We've known about it for at least 40 years now. And the other strange thing is Saturn's south pole doesn't have a similar hexagon storm. So why did it only form on the North Pole and not both or not the South? And so even though we kind of understand that the shape can happen naturally, there are still a lot of things about this giant storm that we don't yet understand, which is why I'm keeping it in the realm of bizarre things in space. All right. Our next stop, still within our solar system, is going to be over at the moon Io. Io is one of the moons of Jupiter. And as we slowly orbit it here, we can see the various colors on the surface. Predominantly yellows, but we also get some reds and oranges and some blacks in there too. Here at the planetarium, we kind of have nicknamed this moon the pizza moon because it kind of looks like a pizza, if you stretch your imagination a little bit. But what's strange about this moon is all of these black spots that you're seeing. Those are volcanoes. Io has over 300 active volcanoes, which is more than anything else in our solar system. It's so active that we have pictures of eruptions that were taking place when spacecraft flew by. We also have pictures of lava flows flowing across the surface of Io. Now, having volcanoes in and of itself isn't weird, right? Earth has them, Venus has them, Mars used to have active ones, they're dormant now. Volcanoes are things that we see on worlds. What's so strange about Io, though, is still the fact that it has volcanoes. And let's talk about why. So Io, it turns out, is just a little bit smaller than our moon. And our moon is what we call geologically dead. There's no active volcanoes. That's because it's such a small world that even though it was hot when it first formed, it's cooled off since then. And you have to have that heat inside of a world to drive activity like volcanoes. The moon doesn't have any active volcanoes because it's cold now. There's no heat left to drive them. Well, Io is a little bit smaller than our moon, which means it should also be cooled off. There should be no heat left in order for volcanoes to thrive, let alone for it to have the most active volcanoes of anywhere else in our solar system. Now, this is a mystery that we do have solved, but it's still really cool, so I wanted to include it. Okay, so along with Io, there are about 94 other moons orbiting around Jupiter. So it turns out that Io is caught in this tug of war between Jupiter and these other moons. So Jupiter is constantly pulling Io towards it, And all of these other moons are pulling Io back the other way, and so it's getting stretched back and forth. And as it orbits Jupiter, how much it gets stretched changes. So sometimes it's stretched out a lot and sometimes not so much. And so it's constantly kind of stretching and relaxing and stretching and relaxing. And what this does is it causes the interior to rub against each other. And just like you do on a cold morning when you want to warm up your hands, as those rocks rub together, they heat up because of friction. And so because of this intense tug of war that Io is caught in, that's actually heating up the interior. And all of that heat is what's driving the hundreds of active volcanoes that we see on Io. So, not a mystery anymore, but still one of the very cool, weird moons in our solar system. So I like to include it in this show. All right, for our next stop, we are going to head out of our solar system. Now, in our solar system, we see two types of planets, right? We see the rocky planets, Mercury, Venus, Earth, and Mars. And then we see the outer planets, which are those big liquid giants that we learned is, the better way to call them. Well, did you know that there are actually planets that could be made of diamond and not just rocks like we have here on Earth? So where we're at right now is a planet called 55 Cancri E. It's also been named Janison. Now, this planet orbits the star 55 Cancri. It's about 41 light years away from Earth. A light year is the distance that light travels in 1 year. It's about 6 trillion miles. And this planet is what we would call a super Earth because it is about 2 times, where's my Earth? There it comes. It is about twice the size of the Earth. So it is a super Earth. And it is about 8 times the mass of our Earth. This planet was actually the first super Earth that we found as we were looking at planets around other stars. Now, this planet is incredibly close to its host star. In fact, it takes this planet only 18 hours to complete an orbit around its star. For comparison, we take 365 days. This planet takes 18 hours. So as you can imagine, being so close to its star, it's incredibly hot. We think the temperatures on the surface are getting up to like 5,000 degrees Fahrenheit. And so as you can see in this artistic interpretation, it is very likely that the surface of this planet is covered in molten rock, lava. Well, I teased you at the beginning that we might have some diamond planets. So here's what's going on. Because this planet is so massive, it's being squeezed a lot, creating really high density. And we think that there is a good bit of carbon inside of the planet. And when you squeeze carbon at high pressures, you can get diamonds. And so based off of some calculations, it's estimated that about a third of this planet could be diamonds. Now, there is some debate over these numbers because there are still some errors in some of our measurements of the different properties of this planet. So we don't know for sure that it is actually a planet of diamonds, but it is possible. And I think that's just really cool. All right. Let's go visit another planet. Now, in our universe, or in our galaxy, we have found several thousand planets. And several of them, as we have found, are actually similar to our Earth, or we think they might be. You know, when we first started looking for other planets out there, that was one of the questions we wanted to answer was, are there planets like Earth out there, or is Earth unique and one of a kind? Well, we are now at a system called K2-18. I know a lot of these don't have cool, interesting names. It's just the way it works sometimes. As you can see, there are 2 planets here around K2-18. And one of them, K2-18b, is within what's called the habitable zone. So the habitable zone, or the Goldilocks zone, is like the distance from a star that you could have liquid water on a planet. And we think that's important because all life on Earth relies on liquid water. So when we're looking for planets that could be like Earth and that could have life, that's one of the things we're looking for. So this planet being in its habitable zone, in its Goldilocks zone, is one check in our kind of list of criteria we're looking for new Earths. So it's in that habitable zone, which means it's the right temperature. You could have liquid water there. Now, the planet itself is another super Earth. Again, about twice the size of Earth, about 8 times the mass of Earth. And in 2019, we actually detected water vapor in its atmosphere, which was really exciting because now we have a super Earth that we know has some water. And since it's in its habitable zone, that means there could also be liquid water on its surface. It could be Earth-like, which is what you're seeing in this artistic rendering. You're seeing our thoughts that this could be an Earth-like planet. So this was kind of one of the top contenders for Earth 2.0, if you want to call it. Now, unfortunately, we no longer think that it's Earth-like. Not too long ago, we found more measurements of its atmosphere, found that the atmosphere was actually a really thick, hydrogen-rich atmosphere, which is going to trap a lot of heat and make temperatures hotter than we thought on the surface. So if there is water on the surface, it's probably superheated, which is not good for life or Earth-like. So now we're not quite sure if this is a super Earth or if it's more like a mini Neptune, where it's a really thick kind of hydrogen atmosphere with maybe a superheated layer of water surrounding a dense core. And that, even though we were excited to find, you know, a super Earth, this is interesting in and of itself because we don't have a planet like this in our solar system. So finding something different is exciting. And that's why, again, it's on our list of strange things because it could be a completely new type of planet that we have yet to find. So we need more information on it. We need more data. But what we were once excited for has now kind of switched to a different excitement about the strange planet K2-18b. All right, I think that's enough of planets. Let's move on to something different. We are going to go take a look at the Red Rectangle Nebula, which is exactly what it sounds like. A nebula is a big cloud of gas and dust in space. This particular one is red and a rectangle, hence its name. Astronomers are not always clever when they come up with names for things. Now, what's strange about this nebula, this is what we call a planetary nebula. So this is what happens at the end of the lives of small stars, stars like our sun. So I'm going to show you a quick little video of kind of what happens at the end of a small star's life. As it gets older, it starts to run out of hydrogen, which is its fuel source, and so it puffs up. And as it does, it kind of loses its hold on those gases, and those gases kind of blow away, and they create this cloud of gas surrounding the dead core of the star, which we call a white dwarf. Now, since stars are spherical, most of the time when we see these planetary nebula, like you're seeing on the left and the right, they're circular because stars are spheres. So when those gases blow off, they're going to blow off in all directions and create a nebula that's also circular. And so that's what's strange about the red rectangle nebula is it's a rectangle, right? We don't really understand yet what happens to turn what should be a circular spherical object into more of a rectangle. It's possible that there were some other things or some nearby things that kind of funneled or pushed the gases as they were flying out into specific directions rather than going out evenly in all directions. But we're not sure yet exactly what caused this strange shape for this planetary nebula. All right. For our next stop, we're going to head to the outer edges of our galaxy and take a look at a globular cluster. So a globular cluster is a group of stars. They tend to contain tens to hundreds of thousands of stars. They're all packed really close together, and they're in a roughly spherical shape. Now, the globular cluster we're looking at is Omega Centauri. The reason this is on our kind of list tonight of weird, bizarre things is it is by far the largest globular cluster that we have ever seen. To give you a comparison, right there in the middle, I just turned on the next largest globular cluster. On average, globular clusters, again, have tens to hundreds of thousands of stars and are generally 10 to 60 light years across. Omega Centauri has 10 million stars and is 150 light years in diameter. Much, much, much larger than any other globular cluster. And of course, that has astronomers scratching their heads of why is there one mega globular cluster when all of the others are more similar in size? And this is one bizarre thing that, again, we do have an answer to, or we think we have an answer to. We think, and while I talk about this, I'm going to kind of show this really cool video, just kind of panning across Omega Centauri, because it's gorgeous. But we think that this globular cluster is actually not originally part of our galaxy and not originally a globular cluster. We think that Omega Centauri is the core of a small galaxy that the Milky Way essentially ate. Galaxies all the time will merge and combine together. Our galaxy is still merging with smaller galaxies surrounding us, which we call dwarf galaxies. And so we think that that's where this Omega Centauri came from, that it was a dwarf galaxy. The rest of it got kind of stripped off and incorporated into the Milky Way as it merged. But the core had enough stuff that it was able to hold itself together. And so it's now left as what we now call a globular cluster. But that would explain why it's so much bigger and has so many more stars than all of the other globular clusters that we see. All right. Well, we have two more things to take a look at. For our penultimate object, we are going to travel out into the universe, into the realm of the galaxies. Now, as we have studied galaxies, we have found that they come in three main types. We get elliptical galaxies, spiral galaxies, which are like our own Milky Way, and then everything else is considered an irregular galaxy. You can see that they're very irregular in shape. They have no real structure, well-defined structure to them. But every so often, we find a galaxy that doesn't quite fit this scheme. Enter Hoag's object. This galaxy is weird. We see a center that looks kind of like an elliptical galaxy, but then it's surrounded by a ring of other stars. So not a disk or a spiral disk like the Milky Way, but not just an elliptical, because there's more than just the central part, right? And it has a well-defined shape, so we can't really call this an irregular galaxy. And this object has astronomers really puzzled, because we do not understand how a galaxy like this could have formed. Because we know that the two main parts, the center and that ring, are different ages. And we know that from the colors. You see, when stars form, you get a whole range of sizes of stars that form, from big blue stars to small red stars. But the big blue stars have a much shorter lifetime. They live and die real quick, at least, in astronomical terms. Small red stars live much, much longer lives. So when we see something like the center that is an orange-red, that tells us that all of the blue stars have lived and died, and we're just left with the red stars. So that central area must be older in order for just the red stars to still be alive. But this ring we see is bluer in color. That tells us those blue stars are alive, which means this ring must be a lot younger in order for the blue stars to still be there. So somehow, what started as probably an elliptical galaxy acquired a ring that formed some new stars around it. And we don't know how that happens. We really don't. There have been lots of possible simulations to try and form this type of galaxy. And since we found Hoag's object, we have actually found a couple of other, what we now call ring galaxies that are like Hoag's. But we still really can't explain what's going on or how it formed. It's weird. It's weird. And I love it. It's so cool. But yeah, that's Hoag's object. All right. For our very last topic, we of course, oops, go away, Hoag. Oh, I know what I did. Here we go. Click the wrong button. There we go. For our very last topic, we can't talk about weird things and not talk about black holes, because they are great prime examples of strange things in space. So, black holes come in different sizes. These small, what we call stellar mass black holes, are the result of the death of massive stars. When they die, they explode in what we call a supernova. And then what's left behind, if it's massive enough, will actually collapse in on itself and form a black hole. A black hole is simply a region in space where you have so much mass confined to such a small volume that gravity is at its extreme. And nothing, not even light, can escape from it. And that's why they're black. Now, in addition to these small stellar mass black holes, we also find in galaxies large supermassive black holes, which instead of being, a couple of suns worth of stuff packed in there, a supermassive black hole like the one at the center of our galaxy, Sagittarius A star, holds 4 million suns worth of material. And then we think somewhere in between, there are also intermediate mass black holes. Now, even though we understand how the small ones form, we do not understand supermassive black holes. We don't understand how these things form. We thought maybe you had just a bunch of small ones that merged together and built up to become these supermassive black holes. But the problem is, as we're looking at galaxies with very, very young galaxies, we're finding they have giant black holes at their center a lot sooner than they should, if that's how those black holes are forming. If they're forming from a bunch of small ones merging together to create bigger and bigger ones. So we are still trying to figure it out. We're still trying to figure it out. How these supermassive black holes that we find at the center of almost every galaxy, how they form and come to be. And of course, on top of that, there's also the mystery of what's going on inside of a black hole, because our understanding of physics completely breaks down once we go into the black hole. So there's a lot of mysteries here. But to end us, I want to show you some cool things. The Event Horizon Telescope, which is actually a series of telescopes all around the Earth, have been working together to get pictures of these supermassive black holes at the center of galaxies. So this is our Sagittarius A star. What you're seeing, the bright, is what's called the accretion disk, the gas and stuff swirling around the black hole before it falls in. And then the first one they actually got was the picture of M87's black hole. Now, this is a giant galaxy. So its supermassive black hole is much larger compared to ours. So you can see ours is that little circle in the left picture inside of the one in M87. There are supermassive black holes that completely dwarf the one in our galaxy. And yeah, we don't understand how they form. They're weird. They're strange. And I think that is a fantastic way to end off our look at the bizarre and strange things in space. So that brings us to the end of our show. I'm going to bring our lights up. Are there any questions? Is that a hand I see up there? Yeah, what's your question? What's inside a black hole? We don't know what it's like inside a black hole. We know it has to have, a bunch of stuff, because that's where its mass comes from. But we don't know what it looks like or what that stuff is like in there. We don't know yet. That's something that astronomers and physicists are still trying to understand. So if you want to know the answer to that, you could become an astronomer one day and help us figure that out. Any other questions? No? All right, well, if you do end up thinking of any, I will still be here for a little while after the show. Thank you so much for coming out. I hope you enjoyed the look at Beyond Bizarre. Before you head out in front of the TV at the main entrance are some star charts. You're welcome to take one of those with you. If you want to do some stargazing this month, it'll show you what's up in our night sky. And yeah, again, thanks so much for coming out. Have a safe trip home and a wonderful rest of your week.